A door frame cannot be considered a raceway according to electrical codes and standards. A raceway is defined as an enclosed channel designed expressly for holding wires, cables, or busbars, with additional functions as permitted in the National Electrical Code, or NEC. Door frames are structural components of a building and are not designed or approved for use as electrical raceways. Using a door frame as a raceway would violate numerous safety regulations and could create hazardous conditions. Firstly, insulation damage is a primary concern. Electrical conductors need to be properly insulated to prevent short circuits, ground faults, and electrical shocks. Running wires through a door frame could subject the insulation to abrasion, compression, or punctures, especially if the door is frequently opened and closed. Over time, this damage could compromise the insulation, leading to electrical hazards. Secondly, proper support and securing of conductors is critical. The NEC requires that electrical conductors be securely fastened and supported to prevent strain on connections and terminals. Wires run through a door frame would be difficult to properly secure, potentially leading to loose connections, arcing, and overheating. Thirdly, there's the issue of accessibility for maintenance and repairs. Electrical wiring must be accessible for inspection, maintenance, and repairs. Concealing wires within a door frame would make it difficult to access the wiring without causing damage to the door frame or the wiring itself. Fourthly, grounding and bonding are essential for electrical safety. Metallic raceways must be properly grounded and bonded to provide a low impedance path for fault current, reducing the risk of electrical shock. A door frame, even if metallic, is not designed to be a grounding conductor and would not provide the necessary level of protection. Fifthly, code compliance is non-negotiable. The NEC specifies approved wiring methods for various applications. Using a door frame as a raceway would not comply with these requirements and could result in code violations, fines, and the potential for rejection during inspections. For your specific situation involving power for a door opener, an exit sign, a fire alarm, and a security system, several approved wiring methods can be employed. Considering you have power coming from both above and the side, careful planning is essential to ensure compliance with electrical codes and safety standards. For power to the door opener and the exit sign, using conduit is a suitable approach as you initially suggested. From the bottom, you can stub up conduit to feed the door opener and the out sign. From the top, you can stub down conduit for the fire alarm and security system. For the emergency power to the exit light, running metal-clad, or MC, cable from above is an acceptable method. Regarding the use of flexible conduit, or flex, remember that it has specific limitations and requirements. It's typically used for short runs where flexibility is needed, such as connecting to motors or equipment that may vibrate or move slightly. When using flex, ensure it is properly supported and terminated with approved connectors. The length of the flex should be kept to a minimum to reduce voltage drop and impedance. Here are some acceptable alternatives for wiring these systems. One approved method is to use electrical metallic tubing, or EMT conduit. EMT is a thin-walled metallic conduit that is lightweight and easy to install. It can be bent to navigate around obstacles and is suitable for dry locations. EMT must be supported at specific intervals, typically every 10 feet, and within 3 feet of boxes and fittings. Proper connectors and couplings must be used to ensure a secure and grounded connection. Another option is rigid metal conduit, or RMC. RMC is a heavy-walled metallic conduit that provides excellent mechanical protection. It is suitable for both indoor and outdoor applications and can be used in corrosive environments with the appropriate coatings. RMC requires more effort to install than EMT due to its weight and the need for threading, but it provides superior durability and protection. A third alternative is to use electrical non-metallic tubing, or ENT. ENT is a flexible non-metallic conduit that is often used in concealed locations, such as within walls or ceilings. It is lightweight and easy to install, but it is not suitable for use in exposed locations where it could be subject to physical damage. ENT must be supported at specific intervals and terminated with approved connectors. A fourth possibility is using MC cable. MC cable consists of insulated conductors enclosed in a flexible metallic sheath. It is commonly used for both power and lighting circuits and can be installed in exposed or concealed locations. MC cable must be supported at specific intervals and terminated with approved connectors. When using MC cable, ensure that the metallic sheath is properly grounded. Considerations for each system are as follows. Firstly, for the door opener power, run conduit from a nearby power source to a junction box located near the door frame. From the junction box, run flexible conduit to the door opener. Ensure the flexible conduit is long enough to allow for the door's movement without putting strain on the wiring. Secondly, for the outside power, run conduit from the same power source or a separate circuit to a junction box near the outside. From the junction box, run flexible conduit to the outside. Make sure to use appropriately sized conductors for the load requirements of the outside. Thirdly, for the fire alarm system, follow the requirements outlined in the National Fire Alarm and Signaling Code, or NFPA 72. Fire alarm wiring must be installed in conduit or enclosed raceways and must be separated from general purpose wiring. Use fire-rated cable and connectors to maintain the integrity of the fire alarm system in the event of a fire. Fourthly, for the security system, run conduit or MC cable from the security system control panel to the door frame. Install sensors and wiring according to the security system manufacturer's instructions. Ensure that all connections are secure and tamper-resistant. Fifthly, for the emergency power to the exit light, MC cable is a suitable choice. Run the MC cable from the emergency power source to the exit light. The emergency power source should be a generator or an uninterruptible power supply, or UPS, that is automatically activated in the event of a power outage. When selecting conductors, it's essential to choose the correct size and type for the application. Firstly, determine the ampacity requirements for each circuit based on the load it will serve. Use the NEC tables, such as Table 310.15b16, to determine the allowable ampacity of conductors based on the size and insulation type. Secondly, consider voltage drop. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the impedance of the conductors. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Use voltage drop calculators or tables to determine the appropriate conductor size to minimize voltage drop. Thirdly, choose the appropriate insulation type. Conductors are available with various insulation types, such as THHN, THWN, and XHHW. Each insulation type has different temperature ratings and moisture resistance properties. Select an insulation type that is suitable for the environmental conditions of the installation location. Proper grounding and bonding are critical for electrical safety. Firstly, ground all metallic raceways and enclosures. Grounding provides a low impedance path for fault current, reducing the risk of electrical shock. Use grounding bushings and bonding jumpers to ensure a continuous ground path. Secondly, bond all non-current carrying metal parts. Bonding connects all metal parts to the grounding system, preventing voltage differences that could create a shock hazard. Thirdly, use a dedicated equipment grounding conductor, or EGC. An EGC is a separate conductor that runs with the circuit conductors and is used to ground equipment and enclosures. The EGC must be sized according to the NEC tables, such as Table 250.122. To ensure safety and code compliance, firstly, always disconnect power before working on electrical circuits. Use a voltage tester to verify that the power is off before touching any wires or terminals. Secondly, follow all applicable electrical codes and standards. The NEC is the primary electrical code in the United States, but local codes may also apply. Consult with a qualified electrician or electrical inspector to ensure that your installation meets all requirements. Thirdly, use approved materials and equipment. Only use electrical materials and equipment that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. This ensures that the materials and equipment have been tested and meet safety standards. Fourthly, protect conductors from physical damage. Run conductors in conduit or raceways to protect them from abrasion, impact, and other forms of physical damage. Use strain relief connectors to prevent strain on conductors at connections and terminations. Fifthly, properly support and secure conductors. Support conductors at specific intervals to prevent sagging and strain on connections. Use cable ties, clamps, or other approved methods to secure conductors in place. For your specific situation, considering the presence of both regular power and emergency power circuits, it's essential to maintain separation between these systems to ensure that the emergency power system functions correctly during a power outage. Firstly, physically separate the wiring. Keep the wiring for the regular power circuits and the emergency power circuits physically separate from each other. Run them in separate conduits or raceways, or use barriers within enclosures to prevent contact between the two systems. Secondly, use different colors for the conductors. Use different colored conductors for the regular power circuits and the emergency power circuits to easily distinguish between the two systems. For example, you could use black for regular power conductors and red for emergency power conductors. Thirdly, label all circuits and equipment. Clearly label all circuits and equipment to indicate whether they are part of the regular power system or the emergency power system. Use permanent labels that are resistant to fading and moisture. Consider the requirements for fire-rated construction. If the door frame is part of a fire-rated wall or partition, any penetrations through the wall or partition must be properly sealed to maintain the fire rating. Use fire-stopping materials to seal around conduits and cables that pass through the wall or partition. Ensure that the fire-stopping materials are approved for use with the specific type of conduit or cable being used. Always consult with a qualified electrician or electrical engineer to ensure that your electrical installation meets all applicable codes and standards. Electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from electrical hazards.